everyone, and welcome to this ALDIC tutorial video. This tutorial will be focusing on the TySOM-M, a compact SoC prototyping board that features Microchip's PolarFire SoC. This embedded development board features a multi-core Linux-capable processor subsystem based on the RISC-V ISA. To properly utilize the benefits of this board, we've created this tutorial on how to bring up the Linux OS on the TySOM-M board. Now let's begin. You can download the board support package containing all the necessary files for booting Linux on the TySOM-M board from ALDIC's GitHub repository. This repository contains a set of bare metal applications, scripts for generating libero designs, documentations that include the quick start guide for the board, and the Linux guide. There's a patch for Heart Software Services, the MSS configurator project for the board using Libero 2021.1, and the Yocto project layer used for building the Linux image. This is the port layout of the TySOM board. The board includes many ports, including 2 USB ports, an SD socket, HDMI, QSFP, and many more. First, go to the directory where the Yocto board support packages are located. Then, source the PolarFire Yocto project setup script. If everything goes smoothly, the current directory should switch to the build subdirectory. Next, add the bitbake layer specifically designed for the TySOM-M board. Once that's done, you can start the Linux build process. Keep in mind that this process might take up to 2 hours, depending on your computer's processing power. When the build is successful, you'll find the Yocto image and binaries in the following directory. This GZ file mentioned in the caption is used for booting Linux on the board. Next, we prepare the SD card by inserting the card into the reader and connecting it to your workstation. Check the name of the SD card using the dmessage command. In this example, it is called SDA. Then, copy the Linux image to the SD card using the command shown. This part will take several minutes. To generate a hex file from HSS, you'll first go to the HSS directory in the downloaded board support package. Then, execute the HSS shell script. This will download the Microchip HSS repository and patch it with the support for the TySOM-M board. Next, you'll have to change directory to Heart Software Services and copy the def config file, as you will see in the demonstration. You can build the hex file from terminal using the make command or by using soft console with the GUI. If you're using soft console with the GUI, you'll first need to import the generated HSS project. Next, right-click on the HSS and click on Build Project. As you can see, the building process has started, and this process will take a few minutes. After building, the hex file will be located in the default directory of Heart Software Services. Now to generate the libero design, click on Project and then Execute Script. Next, select the script from the appropriate design directory. This example will use Design 4. Executing the script will take some time. Once executed, the MFS configurator will open. Don't change anything and just close the window and save changes. Here is what happens when the execution script command is successful. Now click on the Generate FPGA Array Data and run after design generation. The synthesize and place and route stages will proceed this process automatically. Next, you'll include the hex file from HSS to the Libero design. Now click on the Configure Design Initialization Data and Memories, ENVM, Add, Boot 1 Mode Client. From here, select the hex file from Hart Software Services default directory, click Open, and then OK. Remember to save the changes. Select Generate Bitstream and then Run to generate the bit file. Power the board and connect the Flash Pro using USB for the machine and JTAG for the board. Use the USB J6 port for board-to-computer connection and insert the SD card. In Libero, select Run Program Action. Open up any serial monitor tool. In this recording, Teraterm is used. Set baud rate to 115/200 and open all 4 COM ports assigned to the TySOM-M. The board should then boot automatically when finished. Turn power off, then back on if the boot process for the first time does not start. As you can see in the recording, the boot process is taking place. When booting is done, you should now be able to log in to Linux. First, type root in the login section. Then, change directory to the following. This directory contains test scripts that you can run by typing // and then the name of the test. The test will take about a minute. The terminal should return test passed when it's finished. And there you have it. With the ability to bring up the Linux OS on your TySOM-M board, you'll now have a better time designing and prototyping. Thank you for watching.